This video is designed to resolve an obvious and understandable misunderstanding, and that is what you're expected to get for a Lewis structure. Sometimes the expectation is that the Lewis structure you're going to develop based upon the methods you've been taught is not going to give you the proper Lewis structure. And that's because realistically, you cannot derive that structure a priori. In other words, you cannot derive it from theory. You need experimental data to tell you what the right structure actually is. So what I'm going to do is show you SO3 or sulfur trioxide as an example. Now, structure B that you're looking at right now is the correct structure. If you Google it, that is what you will get. However, you shouldn't have gotten that as an answer because you don't have the tools to determine that unless you have extra experimental evidence. So let's talk about the structure you should have gotten. Okay, we can talk about, and then we can talk about what information they might give you that would tell you that structure A, which we're going to do right now, is not correct, and that structure B is correct. So let's say you're doing sulfur trioxide. You have 24 valence electrons. You took your sulfur in the middle, and you put 3 O's around it, and you start putting your dots in like you're supposed to, and you count them as you go. And when you're done, now I've used 24 electrons, and my sulfur is missing a pair of electrons. So you hit the erase button, you erase 2 electrons, and you draw an extra bond in there. Now, this thing has 4 bonds in 3 positions, so it has a bond order of 1.3 repeater. All right. The formal charges are as follows. Sulfur has a formal charge, has 6 valence electrons to start, and has 4 now. So its formal charge is now, this is for sulfur, is equal to positive 2. 2 of the oxygens have a formal charge of, let's see, 6 minus 7. 6 minus 7, which is negative 1. And one of the oxygens, I'll put a comma in there to make it more clear, has the formal charge of 0. It's 6 minus 6 equals 0. All right. Now, by the way, the 2 negative ones, this does add up to 0 because it's right, since times 2. However, for this structure over here, the formal charge is better. So if they had said, well, the formal charges for all the atoms in the structure are 0, then you'd be like, oh, I got to figure out a structure that meets that criteria, right? I didn't give you that, though. In this case, the sulfur is like 6 minus 6, which is 0, and each of the oxygens is 6 minus 6, so everything has a formal charge of 0, which is a more likely structure. But they can't expect you to pull that out of a hat. They would have to say, oh, here's the formal charges on the sulfurs and the oxygens. That's how I know it's got to be that structure. Or they could give you information about bond enthalpy. So they could say the bond enthalpy for a single bond between sulfur and oxygen is 3A7, and the bond enthalpy for a double bond is 523, and the bond enthalpy is 523. If this structure, the one on the left, was correct, then the bond enthalpy would be like 400, somewhere closer to 3A7, because it's got a bond enthalpy of 1.3, so it's kind of like more like a single bond than a double bond, right? So the bond enthalpy would be closer to that of a single bond, right? And the bond length would tell you that as well. So if they tell you that the bond lengths are all they say double bonds are 146 picometers and single bonds are 158, and all the bond lengths are about 145 picometers, well, they're telling you they're all double bonds, right? But without that information, you're not expected to draw that conclusion. So you're not expected to always get the correct Lewis structure. You're expected to be able to compare structures like these two and evaluate them. So if they were to give you these two structures on an AP exam, say, okay, which one is the correct structure? Well, they'd have to give you extra information to make that determination because both structures are valid Lewis structures. The structure B has better formal charges, okay? Okay, the structure matches the bond enthalpies and the bond lengths that would have to be given to you, but you're not supposed to know or memorize those things. They have to give them to you. So do the Lewis structures the right way. Don't Google them, because when you get the AP exam, you're not going to want to do that. They're going to expect that you're going to do the structure to the best of your ability, and if they give you other information, you may have to evaluate structures, and that's the critical thing. You can't get Lewis structures just from theory. You get them from experimental evidence. You break bonds in chemical reactions and you find out the enthalpy, right? You use X-ray crystallography, right? So you get a crystalline structure of some molecular substance, and the X-rays go through it, and they form a pattern of diffraction, and that pattern tells you how they're arranged in three-dimensional space and how far apart they are. and they put those pieces of evidence together to determine what structure is actually correct. I hope this really helps resolve this. Thank you and have a good day.